joined by CBS News space consultant Bill Harwood. Bill, it's good to be with you again. Before we get to the exploding part, what was innovative about this launch in the first place?
I don't even know where to start on that one, John. You know, it's the biggest rocket ever built. It's the most powerful rocket ever built. The first stage has 33 methane-burning engines that are generating 16 million pounds of thrust at liftoff. And just to put that in perspective, that's twice what the legendary Saturn V rocket produced, or even what NASA's SLS moon rocket did that we all marveled at a couple of months ago. But I think the real key to the Starship, it's fully reusable. First stage and second stage are designed to be recovered, refurbished, and relaunched. And the dream is that that will drastically lower the price of putting people and cargo in space. So was it an achievement just to get this off the ground, given that just how gargantuan and massive it was and all the moving parts? And I mean, is that, as we count up the levels of success before we get to the part that went wrong, is that, give us a sense of how much of an achievement that was? Yeah, I think it was clearly a big achievement. You know, launching a rocket that big has never been done before. You know, you got the whole launch gantry, the launch pad had to be able to withstand that stress. And it did apparently take quite a bit of damage from the pounding it got from those engines. But just safely getting that thing up through the lower atmosphere, you know, there's a region in a rocket launch they call maximum aerodynamic pressure. That's where, as it's powering out of the lower atmosphere, the stress builds up to a maximum, and then it starts dropping away as you get higher and higher. The rocket got through that point. So I think those were major achievements. But when you look in the record books, I think you have to put an F by this one for failure. They did not get to space. They did not recover the second stage, and they, you know, and ultimately didn't achieve their primary objectives.
So, what caused this? What went wrong?
We're not sure yet. You know, when you watch the video, it looks like about 6 engines of those 33 in the first stage either shut down early or were forced to shut down because of some other problem. And then about 2 minutes into flight, the exhaust plume on the rocket appeared to get asymmetrical. I mean, something clearly was going on at the base of the rocket, and it ultimately tumbled. And then 4 minutes after launch, you know, it's equipped with a self-destruct system. The computer triggered the explosives to go off just to make sure the vehicle didn't land somewhere intact and cause any damage. So unclear yet. We're going to have to wait and see what the data shows and what SpaceX reveals to us to get any sense of how long it might take them to recover and try this again.
And given how little we know, is it possible to know what they might learn from, or areas where they can see some areas where they might learn to try this again?
Oh, no question about that. You know, these rockets today have all kinds of sensors on them. It's beaming back torrents of telemetry all the way up. I have no doubt when the engineers go through that data, they're going to get a pretty good idea pretty quick about what went wrong, and then they'll have to try to fix that. But it's just impossible to say at this stage how long that might take.
All right, Bill Harwood, always a pleasure to be with you at the Kennedy Space Center. Thanks, Bill.
Thank you.